Arranging your widgets within a J-frame can be pretty frustrating. Swing provides a number of layout managers to help. We started learning Swing by using a FlowLayout, which puts the first widget in the top left corner and each additional widget gets placed to the right. Once it reaches the edge of the container, it starts a new row. So it works basically like Microsoft Word. Your typing just goes across from left to right, and when you get to the right edge, it bumps your new word down to the next line. FlowLayout is easy to use, but the results can be confusing for the user. In this example, the text boxes can get separated from the labels that tell the user what to input. Resizing the window demonstrates how the FlowLayout adjusts and wraps widgets to the next row. And you might be able to dial in a width that kind of makes sense, so I guess you could just set the size to that. I could also set the preferred size for these different widgets to help keep things looking consistent and also control where those new rows are started. It's not really ideal, but it can work for simple GUIs. And note that though I didn't show it here, you can change the alignment of widgets within the FlowLayout by adding that as a parameter in your constructor call. One thing that can help is grouping widgets together. Swing provides a class called JPanel that is basically a generic container that will hold widgets. In this example, I've added a JPanel as one of my fields and instantiated it in the constructor. I've also set the background color so we can see the panel when we run the program. The panel is going to hold widgets related to John. Next, I'm going to add the label and text box to the JPanel instead of to the frame, and then I'm going to add the panel to the frame. You can see the red background showing that the JPanel is holding our label and text box, and now when I resize the window, the JPanel is treated as a single widget. That keeps them together when we get to the right edge of the frame. I can use as many panels as I need, so I'd probably want to put each label text box pair in separate panels so they always stay together. But there's also life beyond FlowLayout. A really straightforward layout manager is the GridLayout, which establishes a grid of cells that you can use to arrange your widgets. When you set the layout, you'll add the number of rows and columns to the GridLayout constructor call. In this case, I've made a grid with 3 rows and 2 columns. When you add widgets to a grid layout, they are put in from left to right and top to bottom. So here's the result. The grid will fill the entire container and the cells are going to be the same size. By thinking about your GUI as being in a grid, you can often sketch out the basic layout on a sheet of paper or in a table in Microsoft Word, and then write the code to produce that. The other layout manager we'll look at here is called BorderLayout. This lets you position widgets in different regions of the container, like the top or bottom, left or right. In this example, I've created 5 different JPanels and placed them around the frame in the positions indicated by the labels. Page start and page end are at the top and the bottom of the screen.
Line start and line end
Are the sides, and center is, well, the center. To use this approach, you'll specify BorderLayout as the layout for the frame. You'll specify the position of each widget when you add them to the frame using predefined constants, actually enumerations, that are available in the BorderLayout class. I've added labels to the panels, and now I'll add the panels to the frame. BorderLayout.pageStart puts the first panel up at the top, for example. There are different constants you can use. For example, you could specify BorderLayout.north for the top of the screen, and east, south, and west for the other regions. They behave a little differently than page start and page end, for example, so you can experiment with those directional references to see the difference. There are a bunch of other layout managers in Swing, too many for us to cover here. But we haven't yet seen the most useful trick for organizing the layout of widgets: nesting. Often there isn't a layout manager that works perfectly for what you're trying to accomplish, like in this example. This color-coded version helps visualize the way I've laid out these components. The pink color is the frame itself, and the label is added directly to that. The teal is a panel, and I've applied a 3x2 grid layout to that panel before adding the checkboxes. The orange color represents a separate panel with the button, and it's really just to demonstrate an additional panel. So that gives us three elements: the label, the checkbox panel, and the button panel. And I've added all of those to the frame within a flow layout. Using panels with their own layout managers gives you a ton of flexibility. Now, I often use a restaurant analogy when I talk about decoupling code from a user interface. The GUI is front of house, like the servers and bartenders, and the classes we write are the back of house, like the cooks. There's a similar analogy related to GUI design itself, and it's based on one of my golden rules of coding. Programmers are terrible at UI design. You can always tell when a user interface was created by a programmer because it sucks. Okay, that might not always be true, but it brings up this idea of using specialists. The cooks don't have to have great people skills because they can focus on cooking. The servers don't have to know how to cook, and they can focus on good customer service. It makes both of them better at their jobs. And most importantly, it makes for a better experience for the customers. In software development, it's often better if a coder can just focus on writing code, and then we can get someone with a great design background to develop the GUI. To help with this, there are tools that allow someone to lay out a GUI, and the tool will generate the swing code to produce that GUI. That makes it possible for a non-programmer to lay out a good user interface. I mention this because I want to acknowledge that those tools exist and can make our lives a lot easier. But in this course, we're learning how to write code, so we won't be using tools to create our GUI for us. On my assignments, you need to write the GUI code the old-fashioned way, but I encourage you to explore some of those tools outside of class. And as is almost always the case with these videos, there's a lot more out there that I haven't had time to cover, but this should give you enough flexibility to create the GUIs you need for your own programs.